my phone. Okay. So, I went back and watched the video this morning. Here are the points of interest that I wrote down. Are you ready? The regression line is the same thing as the line of best fit, which you learned in Math 1. Y equals mx plus b. However, we changed it from y equals mx plus b to what? A plus bx. And what does that equal? Y hat. Why a hat? It is a prediction. Y is, hey, this is what it is. Y hat says, this is what I predict it will be. One of the big reasons why students lose points on their quiz, they forget the hats. And they forget the word predict. You can't tell me that this is what I'm going to sell my truck for. You can tell me that this is what I predict you will sell your truck for. If you use a formula, you write it ahead of time. So if you're going to plug stuff in to find a prediction, you're going to write y hat equals 57 plus 6.2x. Then you're going to plug in your x and solve for y hat. You're going to show all your work. You're going to show me that you're plugging in that number and where you're plugging it in. Because if you screw something up on your calculator, I can still give you points as long as I knew your process was right. When you define your variables, when you have y hat equals, I don't know, 7 minus 3x. And let's do this. And we are predicting, I don't know, the grade based on how long you've studied. You have to tell me that x is the number of hours studied. Sorry. And y hat is what? The predicted grade. You have to define your variables. Okay. This regression equation only relates these two variables together. It does not take into account that you broke up with your girlfriend the night before the test and you went in on 2 hours of sleep and puffy eyes and hurt feelings and tanked your test. Those are confounding factors. Or that your dog ran away that morning. Or that you woke up and your mom made you the best homemade breakfast ever and you had the best night's sleep and you feel so good and oh my goodness and life is amazing and here I go. All of these confounding factors come into play. This does not account for any of those. This just accounts for these two variables. Input, output. Explanatory response. Tell me about extrapolation.
When they ask you to predict something that's out of your data set.
Oh, that's beautiful. When they ask you to predict something that's outside of your data set. So for the truck problem, if my trucks go from 4,000 miles to 150,000 miles, and I ask you to predict how much can I sell my truck for, and I got 250,000 miles on it, can you use that equation to answer that question? No, because it is extrapolation, and you're going to drop that word. You're going to use that word in your explanation. That would be extrapolation. We only know that this equation holds for the data that's in between my max and my min. I don't know what the linear model does outside of that. It could change. And for trucks, it does change, doesn't it? Let's talk about residual. What's the formula for residual? Y minus y hat. Y is the observed y, what actually happened, what you see in your table. Y hat is what should have happened. So, let's say I'm selling my truck. It's got 37,000 miles on it. I sell it for 12 grand. Is that 12 grand a Y or a Y hat? That's a Y, because that's what actually happened. Now, I'm going to use my prediction equation, plug in a 37,000, and get a predicted sell value of $13,500. Tell me about my truck. Yeah, something's off, something's wrong, it's probably damaged, or it might be in bad condition, or it might be like baby poop brown, whatever, but I'm not selling it for what it is predicted to sell for. So what would my residual be? Negative 1,500. Because it is always Y, what actually happened, minus the predicted. So if I were to think about my graph, what is the blue line? Right? Who is on that blue line?
White hats.
White hats. Make sure that makes sense. Does that make sense? Those are all my predicted. Because I'm going to get all these values by plugging them into the equation of that line. So when I do that, that 13.5, that's on that line. Where's my 12,000? Here's 37,000 miles. That's what he's supposed to sell for. There's what he actually sold for. So my residual, y'all said, was negative $1,500, right? That is the distance between that piece of data and that regression line. Negative if the piece of data is below it. Positive if it is above it. But the residual is that gap, it's the vertical distance. So this guy up here, tell me about his residual. Big positive. Yep. Tell me about that truck.
Really good shape.
It's in really good shape, or it's in really high demand. Yep, because he sold for much more than he is predicted. All right. Okay, how can I get every single individual residual without having to find them all out? Not residual plot. I don't want to graph them yet. I'm just asking, where can I get those values? L3. Now, I said it several times in the video because I heard myself say it this morning. What do you have to have done? That didn't make sense. What must you have done before your calculator will produce residuals?
Stat. You have to remember A.
Yep, you have to get the equation of the line. You have to let your calculator calculate the equation of the line. So you have to do stat edit number 8. Then your calculator has the equation. Then it says, okay, now I can go find residuals. But if you go over to L3, where is resid? Where is it? Huh? Somebody tell me where resid is on your calculator. What buttons do you push?
Second list.
List.
Yeah, usually so.
Is it second list?
Yeah. No, second stat. Second stat.
So list, which is second step.
Yeah.
Okay. So list, and then is it right there?
Yeah.
Down at the bottom?
Yeah, 7.
Number 7?
Yeah.
So if you don't see him there, what have you not done? You haven't let your calculator find the equation yet. Your calculator will not offer to find you the residuals until you allow it to get the equations. You have to do that step first. Then you go to L3. Oh, come on. You can do it. I promise. Come on. You can go over to L3. See, mine's not going to let me do it because I don't even know what this data is from. So second list. Oh, I do it. That has found the equation. So then I go 7, and then I hit enter, and poof, there they are. All those bad boys boys are the what? Okay, so which piece of data is farthest away from the line? The 30. That piece of data is 3.2 away from the regression line. So he has the biggest residual. Does the residual have to be positive to be big? Because what does negative mean? It's just below the line. But the residual, it can still be a far away distance, right? Okay, that's good. Good. What should the average of all of these be really close to? 0. That means that your line navigated itself through those points in the best possible place. And that's why it's called the least squares regression line. Least because we want the smallest. Why is squares in its name? It was a small piece of video, but it wasn't a video. Some of these are positive and some of these are negative, right? What would squaring them make them? Makes them all positive. Now, it's going to make them all positive, and then when I add them together, am I going to get 0? No, but I want that to be the smallest number possible. So I want the smallest, least, squares, because I'm making them all positive, so I'm going to square them all. Regression line. So I want that number to be the smallest possible number. That means I have the smallest distances between those points and that line. That means that line is situated just right to have overall that smallest least squares regression. Go with that. All right. How do you graph a residual plot? Yes? Yeah. I want L1, L3. Zoom stat. This is crazy. There's your residual plot. Let me ask you a question. What is this value right here? 0. Because I want it to be 0. So if I've got a dot that's on it, that means his residual is 0. That means his prediction and his observed are the same thing. So right now, these two pieces of data are the closest. He's the farthest away. These two are close behind. Is this, let me rephrase that, is a linear model appropriate for this particular data? Because you can't say it. The residual plot shows a pattern, period. You have to say who and what. The residual plot shows a pattern. Therefore, a linear model is not appropriate. It needs to be scattered. Okay? You need to refer to residual plot and say that it has or doesn't have a pattern. Okay. Now, once you've done that, please remember that when you go back to plot something, that you are now L1, L3. So I'm going to go fix them back to L2 just because. Okay. Who is R squared? I had it a minute ago. R squared. Coefficient thingy. The coefficient of, there it is. Woo! Coefficient of determination. Let's say the trunk's R squared, I don't know what it is. Let's say it's 77%. Here's your rubber stamp sentence. Your rubber stamp sentence see if I can do it without looking. It starts with the variation. Because think about how your data fluctuates, it varies. So the R squared is talking about the fluctuation in your data. So the variation of, now, what is your output for the truck data? The price. So the variation in the price of the truck, whatever, F-150, can be, let's back up, 77% of the variation. How's that? That's better. 77% of the variation of the price, the output, can be explained by or accounted for what? The linear model that relates who and who?
Number of miles driven to the price.
Yep, the miles driven and the price, your two variables. 77% of the variation in your price, because the prices are all over the place. So that fluctuation, 77% of that fluctuation can be explained by the model that relates miles and price. Which means 23% is accounted for by, or counted for from what? Other things, like damage. Not working correctly. Crappy tires. Your girlfriend keyed your truck. All kinds of reasons. All kinds of confounding factors. All of these extra things that are coming at this. But 77% of that variability is mileage. 23% is other stuff. So that's a sentence you need to work on, because there will be a question where you have to write that sentence, and it has to be perfect. Perfect. Okay. If I give you an equation, and I tell you that the R squared is 77%, or 0.77, however you want to look at it. How can you find the R? Like plain R. Okay, grab a calculator. What is the square root of 0.77? Hey, do you need one? Grab it, it's on my desk.
Thank you.
Yeah. Go again.
877.
0.877? Does everybody agree? Confirm his decimals? Okay. Is that your R? Who is R? No. He is your correlation coefficient. Remember R? R fluctuates between who and who?
1 and negative.
1 and negative 1. He tells you the strength of your data. That's R. Okay, but let's hold on a second. R fluctuates between a 1 and a negative 1. You just square rooted. That's always going to be positive. So how do you decide if he gets to be negative or not? By the slope. The slope of your line goes down. Then your R also needs to be negative. Is my slope negative? Then my R has to be negative. But nothing in your calculator is going to tell you that. That's a brain thing. Your brain's got to tell you that. So remember, the R can be positive or negative, and R's sign and the slope sign will always be the same. Always. Okay. Are we good? That's it. That was my list. That was it in a nutshell. How do you feel? Mine's fantastic. All right. Let's dive in. We're going to do almost all of them. That's my goal. That is my goal. Your job is to finish whatever we don't finish. But then, guys, do you have a problem after the homework? It says review problem for quiz. Can you look after your homework? You don't have it? I think I'm right.
It says part two. right?
Okay, so I have a review problem for quiz. It is one problem and a whole bunch of questions. So your homework before Thursday is to finish the homework from 3.2 part 1 and then also to do this. When you come into class Thursday, we will check this, we will go over it with a fine-tooth comb, and then you will take your quiz. That's it. That's all we're doing Thursday. Then Thursday night, you'll watch the last video from chapter 3. And then Monday, we'll do the 3.2 part 2. And then Wednesday, we test review, and Friday, we test. Okay? So I'm gonna go run copies. I want you to start number 35. So just put this little guy right after that homework. Okay. What do we got for 35?
Y hat equals 80 minus 6x.
What do you think? Everybody agree? I agree, but you're not done. You have just introduced two variables. What must you do? You must define them. You can't throw an x and a y hat down without telling me what x equals and what y hat equals. Do you think that's a really big mistake on the quiz? Yes, people get so wrapped up in, oh my God, what are the numbers? What do I do? What do I count? They forget to define their variables. So what's x? What is your input? Do you agree? Number of days? Okay. What's y hat?
Predicted so far.
Predicted soap rate. How's that? What word must you have? There it is. Good job. Good job, guys. Listen, we'll take our successes when we can. Good job. All right, moving on. Everybody good? Boom. 37. We expect a car's highway gas mileage to be related to its city gas mileage. Data for all vehicles. Oh, they gave us the regression line. Predicted highway MPG equals, so they didn't use variables, so this is their y hat, and this is their x. What is the slope of the line? Interpret this value in context. What is the y-intercept? Explain why the value of the intercept is not statistically meaningful, and find the predicted highway mileage for a car that gets 16 miles per gallon city. Go. Go, 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 go. But go quick. This is your homework. Don't make it beautiful. Don't give me beautiful English, lovely sentences. Give me statsy sentences. What is the slope?
1.109.
Okay, so I'm gonna write m equals 1.109 because it just dresses it up a little bit. How do you interpret that? What did I do in the video? I went math 1 on it. I'm gonna put it over 1, and I'm gonna write he's y over x. Because isn't slope y over x? Except this is y hat. See, now it's super easy to interpret because it's for every one of those, this is predicted to increase this much. Like, it's super easy if you'll label it. So for every one, what's x? City mile per, excuse me, for every one increase of city mile per gallon, my predicted highway miles per gallon goes up by 1.109. Okay, one more time. For every, start slope with for every. For every one increase in city miles per gallon, the predicted highway miles per gallon should increase by 1.109, or is predicted to increase by 1.109. Just have that word predicted in there somewhere. So for every one increase of these, this is an increase. Could it ever be a decrease? Yes, if your slope is negative. Well, hat would be predicted to decrease. Okay, what is the y-intercept?
4.62.
Okay, I'm going to write it as a point. 0, comma, 4.62. You don't have to do that. It just helps me. That's what I do. And then I'm going to come in here and label him x and him y hat. Because now it's super easy. Your y-intercept is your starting point. So when, who is x? When this car gets 0 city miles per gallon, it is predicted to what? It's not an increase, a decrease. This is like a snapshot. It will get 4.62 highway miles. It is predicted to get 4.62 highway miles per gallon. So the slope is a changing, breathing thing. Like for every one of these, this is predicted to increase by this. The y-intercept is your starting value. When the city miles per gallon is 0, so when your car gets 0 miles per gallon in the city, it is predicted to get 4.62 highway miles per gallon. Do y'all see the difference between the two statements? Slope is like a moving and a shaking. The y-intercept is a standstill. It's a when this happens, this happens. Explain why this is not statistically meaningful. Logic. Be logic here. Yeah, you can't have 0 miles per gallon in the city. 0 miles per gallon? That means every time you use a gallon of gas, your car got 0 miles? That doesn't make sense. Y intercepts, a lot of times Y intercepts don't make sense. Not always, but a lot of times they don't make sense. Because odds are, guys, the Y intercept is extrapolation. It's outside my data. Okay, find the predicted highway mileage for a car that gets 16 miles per gallon in the city. So who is the 16?
City.
Yeah, he's going right here. But remember what I said, you have to write the formula. So I'm going to go y hat, because they've already defined it up there, equals 4.62 plus 1.109x. Write my formula first. Now I'm going to plug in 16. So y hat equals 4.62 plus 1.109 times 16. Grab your calculators.
Hey, I'm not very good.
Go ahead. 22 point what? 364 miles per gallon. Right? Okay, so if you had to write that in a sentence, which they're not asking you to, but if I asked you to write it in a sentence, interpret this value. State the question, guys.
The predicted
highway miles per gallon is
Yeah, can't stop there.
If
Finish the sentence.
a car gets 16 miles per gallon.
Yes, yeah. I might have started here. For a car that gets 16 miles per gallon in the city, it is predicted to get 22.364 miles per gallon on the highway. But if this happened, then this happened. Or it's predicted to happen. Okay, how do we feel? Slope, y-intercept, prediction. All right. 39. Researchers studying acid rain measured the acidity of precipitation in a Colorado wilderness area for 150 consecutive weeks. Acidity is measured by pH. Lower pH values show higher acidity. The researchers observed a linear pattern over time. They reported that the regression, so predicted pH, equals that equation based on weeks, fit the data well. Identify the slope of the line and explain what it means in this setting. Identify the y-intercept and explain what it means in this setting. According to the regression line, what was the pH at the end of this study? How long did it go? Okay, so there's your value plugging in. So this one mirrors the one we just did. So nail this one. Go. Like nail it. of set up. Did y'all catch the slope was negative? I saw the negative, okay. So let's see, X is what? Weeks and pH. So I would say for every 1 week, the pH balance of wherever we are, is decreasing by 0.0053. What do you think? Everybody okay with that? I'm pausing, letting it process. Okay. Y-intercept. At week, thank you. At week 0, the pH balance is predicted to be 5.43. Awesome. Issues, questions, details, notes and crannies? Everybody got the words predicted in both of those sentences? And I got 4.635 for part C. Are we good? Questions? Ask me questions. I can't tell. I can't read your faces. Everybody's okay? All right. Y'all want to go? All right, moving on to 41. It says, refer to exercise 39. Would it be appropriate to use the regression line to predict the pH after 1,000 months? How many weeks is that? 4,000 weeks? Yeah. So why? Why would it not be appropriate? Because this would be extrapolation, but then tell me why. Since what? So since 4,000 is beyond the 150 weeks? Yes. So no, this would not be appropriate. This would be extrapolation. Because this is asking to predict something far outside the realm of the data collected. Thank you, sweetie. So don't just say, hey, it's extrapolation. Tell me why it's extrapolation. Okay? All right. 43. Oh, this is a good one, I think. Least squares idea. The table below gives a small set of data. Which of the following 2 lines fit the data better? We have y hat equals 1 minus x, or y hat equals 3 minus 2x. Use the least squares criterion to justify your answer. Now, then it swoops in and says, note, neither of these 2 lines is the least squares regression line for this data. Because a lot of people say, well, why can't I just do what? Plug that into my L1 and my L2 and get my equation and see which one it is. Well, they're saying it's not either one, but they want to know which one's better. Okay, so think about why something is called the least squares regression line. What does it want to make least? Squares of what? Squares of the residual. So could I have the equation, I have the actual pieces of data, can you find the predicted pieces of data? Yes. Okay, and then can we find out which one has the smallest total residual? Let me show you what we're doing. These are observed, like this is what actually happened. These are y's. I'm gonna find all the y hats that go for these x's. Well, this is easy, like 2, -1. If I plug in a -1, what are you gonna get? Y'all can do it. Thank you. If you plug in a -1 for your x, this equation is gonna give you a 2, correct? Okay, now plug in a 1, what do you get? Now plug in a 1, what do you get? Now plug in a 3, what do you get? Now plug in a 5, what do you get? So these are all of his wide hats. Go with me? Now, what are his residuals? Now, residual is who minus who? Y minus y hat. So what's 2 minus 2? What's 0 minus 0? Oh dear God. What's 1 minus 0? 1. The third piece of data, the third observed, minus 0, the third y hat. What is 1 minus 0? 1. Y'all, come on. What's negative 1 minus negative 2? Negative 1 minus a negative 2.
No,
1. Do y'all speak? Like,
yeah.
can we subtract? Like, come on. Good Lord. What's negative 5 minus a negative 4? Thank you. Now, what do I do with all those numbers? It's called the least squared. So what do I do with these numbers? Okay, 0, 0, 1, 1, 1. I just squared them all. Now what do I do? I add them all up. What do you get? So that is the sum of his squared residuals. And I want you to go do the other one. Your input is the X. So you're not looking at the Y's right now. You're inputting an X, and you are getting all of the Y hats. So let's make sure we did the first one right. If I plug in a negative 1, what are you going to get? Nope. What are we plugging a negative 1 into? Aren't we over here? Wouldn't that be 5?
Yeah.
Okay, now plug a 1 in. What are you going to get? 1. 1. Oh, I hear voices. Yay. We'll plug a 1 in again. What am I going to get?
1.
I'm going to get a 1. Now plug a 3 in. Negative 3?
Yeah.
I like it. Now plug a 5 in. Negative 7? Now those are all the Y hats. Those are not residuals. Those are the Y hats. How do I get the residual? Yes, every time we talk about residuals, I'm going to point to you. Y minus Y hat. So I need to do Y minus Y hat. What do you get? Negative 3. Why is this difficult? I don't understand. Are y'all just not talking? Do you know? Because I'm worried if you don't know what 2 minus 5 is, like I'm scared. 2 minus 5, negative 3. 0 minus 1, negative 1. 1 minus 1. Oh, good job. Negative 1 minus negative 3. I'm going to write it out. Negative 1 minus negative 3.
2.
Good job. All right. Negative 5 minus a negative 7.
2.
Okay, those are the residuals. What do I do with those numbers? Square them and then add them all together. Oh Lord, what's negative 3 squared? Oh, Positive 9. Negative 3 squared means negative 3 times negative 3. Positive 9. Is this corona dust that we're knocking off? Is this COVID cobwebs?
I'm just tired.
Poor thing. 0, 4, 4. Now add. It's kind of painfully obvious at this point, is it not?
I think it's the first.
Yeah, that's 10. That'd be 18. Who wins? But guys, that is a fantastic problem in, number one, knowing what the residual is, how to find it, and how it can help you pick the better equation. That's a great problem. So, remember this is recorded. So you could fast forward and go watch this part again. Okay? Listen to me beat my head against the smartboard, because y'all can't subtract. All right, 45. In the acid rain study of exercise 39, the actual pH measurement for week 50 was 5.08. Find and interpret the residual for this week. Okay, so what is the 5.08? It is. It is Y. It is the pH value, but you're right. It is Y. Plain Y. But to get the residual, who else do you need? I need Y hat. Well, we had an equation, right? That equation was on
5.43 minus 0.0053.
Is that it? Because I'm old and I don't have a good memory. Is that right? Okay. Okay, so who do I stick and where do I stick it? I need week 50. That's my input. So I'm going to put a 50 right there. So I'm going to write Y hat equals 5.43 minus 0.0053 times 50. I'm going to grab my handy dandy calculator, type that bad boy in. You may confirm that.
Yeah.
Sweet. Is that your answer?
No.
Okay. It said find and interpret the residual. Okay. So now residual does not have a letter. It's not R because R is already taken. So we just gonna call him res. Okay, for residual. So residual, but you have to write the formula first. You can't just throw numbers in here. What's the formula for residual? Y minus Y hat. So who is your Y? Who is the observed? What actually happened? That's the 5.08. What was predicted to happen? So what is his residual?
Negative 0.085.
Okay. So I have found the residual. But what else does this little stinker want me to find? Or want me to do? Okay, so now I gotta interpret what this means. Now he's negative, which means what? He who? The predicted is the line.
The piece of data.
Right, the actual. It means the actual piece of data was lower than what it was predicted to do. Okay, now turn that into a sentence, something about pH, throw pH in there somewhere. So the measurement, I heard measurement, the measurement for week 50 is 0.085, less than or below the predicted pH value for that week. So remember, y hat is what's on the line. Y is the actual piece of data, the dot. So if that's negative, then if your residual is negative, then the y was below. All right, good job. How are we doing? Everybody okay? All right. 47. Bird colonies. Exercise 6, on some page, examine the relationship between the number of new birds, y, and the percent of returning birds, x, for 13 sparrowhawk colonies. Here are the data once again. So we have percent return and we have new adults. Use your calculator to help make a scatter plot. Okay, so we're not going to draw it, but let's practice doing a scatter plot. So grab your calculators and throw this data in there. Now remember to hit clear on your list. Don't ever hit delete. But if you do hit delete, we can fix it. I don't have to. All right, downloaded. How do I get the scatter plot? Where do I go? Stat plot. Boom. Number uno needs to be on. Yep, make sure it's L1, L2. You guys might have an L3 lingering in there from your homework or from the video. So make sure it's L1, L2. Make sure it's on scatter plot. And then how do I see it? Zoom 9. Bad. Okay. So part A, check. Everybody comfortable with that? All right, part B. Use your calculator's regression function to find the equation of the least squares regression line. Add this line to your scatter plot. We're not going to add the line to the scatter plot, but how do I get the equation of the line? First of all, how do I get off of this? Yes, second quit will always get you off of whatever you're on. So second quit. Okay, now how do I get my equation? L1, L2? Boom. Okay, so my equation is going to be, how's it start? Y hat equals 31.934 minus 0.304. What's that? S. Yes. All right. So y hat equals, what was the, I don't have it in front of me. 304?
Yeah.
an equation. You just use two variables.
Oh,
What have you not done yet?
Fine.
You gotta define your variables. X equals, well, look at your chart. What's X equal?
Return.
Percent return.
Yeah.
And what is Y hat? What word must you use? Predicted. I don't have that word for it. Do y'all see how easy it is to forget your variables? Because we've done it twice. It's so easy. Okay, all right, so we did A, we just did B. C says explain in words what the slope of the regression line. Don't write it, let's just talk. First of all, who's the slope?
Clear.
And what am I gonna do?
Over.
I'm gonna put it over 1, and then I'm gonna label Y hat X, because it helps me. Okay, now the slope is a moving and a shaking kind of statement. It's a whenever this increases by 1, this happens to this. So, who is X?
Percent of
Return. So for every
one.
1,
Predicted. No. Percent return.
yes, for every 1% return. Y'all see how that makes sense? 1x. For every 1% return, the predicted new adult birds will decrease by 0.304 birds. Does that make, y'all see how easy that makes it when you label it? For every 1% return, the new adults will decrease by, is predicted to decrease by that much. Easy peasy. Calculate and interpret the residual for the colony that had 52% of the sparrowheads return and 11 new adults. 52, 11, there it is. I want his residual. Well, residual is what?
Y minus Y.
Y minus Y hat. Who do we have?
Why?
Y. The pieces in here are the actual pieces of data. So that 11, that's Y. We're going to get Y hat by using our formula and plugging what in? Do I plug in 11? I plug in 52 in for my X. Go find me Y hat. Who's got a Y hat?
16.126.
16.126. Confirm? Yes? Okay. So there's Y hat. That's not the residual. Residual, and again, I'm going to use my formula, Y minus Y hat. Then I'm going to plug it in. Who was Y for 52? 11. And our Y hat was 16.126. Any chance y'all could do that in your head?
Negative 5.126.
There it is. Negative 5.126. So that is the residual. Now it is negative. I'm talking about birds. And the number of new adults that returned specifically at 52 weeks. No, 52%. So, how could you make me a sentence? gotta involve the word 52, you gotta involve 52 somewhere. The fact that this is negative and this number. So what do you think? What is the 52 again?
Depreciate.
Okay. So when 52% return, what are the Y's again? Look at your chart. What are Y's? The number of adult birds, right?
So 52% of Sparrowhawk's returns predicted that. Confidence, 126, what
No, I liked the beginning of that
not returning, they'll be 5.126 less than the adult.
though. Then what? Then before? Like then week 51? What is the residual find? The difference between who and who?
Why?
The observed and the predicted. Okay, 52 week, no, 52, why do I keep doing that? 52%, if 52% of the birds return. There were,
The predicted birds.
Mhm.
No, the birds.
residual does not have the word, well, it doesn't, don't start with the word predicted.
The percent of birds that returned was 5.126 less than the predicted amount.
You're so, oh my gosh, you're so close. This is not a percent. This is number of birds, number of adult birds, right? If 52% of the birds return, there were 5.126 less adult birds than was predicted. Guys, picture the line. This drop right here is your 5.126. This is what was supposed to happen. This is what actually happened. And this is all at 52% of the birds returning, or whatever that 52% is. When 52% of the birds return, there were actually 5.126 less adult birds than there was predicted to be there. There were predicted to be 16.126. We actually only had 11. Y'all with me? So we're 5.126 adult birds less than what we thought we were going to have. Y'all good? Are you okay with that? Oh Lord, more birds. Use your calculator to make a residual plot. Describe what this graph tells you about the appropriateness of using a linear model. I don't want you to draw it, I just want you to get it on your calculator. See if you can remember how to get the residual plot on your calculator. First, you have to get the residuals. Now, I've already told my calculator how to get the equation. So where do I go?
Stat.
Stat,
Edit.
edit,
Code.
L3. Where is it, guys?
Section.
List, yep. And there he is. Boom.
You go to the second stat line.
Yeah, stat plot. Anytime you want to graph something statsy, go to stat plot.
You would change So why list L3?
Yep, I want to graph L1, L3.
Then you can put in zoom and zoom in.
Zoom none. Is everybody comfortable with all those steps? Anybody have any issues with buttons? Okay, so what do you think? Is a linear model appropriate?
Yes.
Because there's no pattern where? In the residual plot. There is no pattern in the residual plot. Nice job. Now, part B. Which point has the largest residual? And then, God help us, explain what this residual means in context. Okay, who has the largest residual? Well, I can look here and eyeball it. But guys, where are the actual residuals? Yeah, they're in your L3. Go look at your L3. Let's see. I see a 5.3 right there. Yep. I think 5.3. Can y'all beat that one? Y'all see anything above a 5.3?
There's a negative 5.869.
Oh, Jesus. I missed him. Oh, it's right there at the top, that one. Okay. Yeah, let me go all the way. Yeah, I totally overlooked him. Okay, so there is my biggest residual. It is negative. When 66% of the birds return, there are 5.869 less than fewer new birds than predicted. The residual is the difference between what happened and what was predicted to happen. Oh, that's a good sentence. I'm going to say that again. The residual is the difference between what actually happened and what was supposed to happen. If 66% of the bird population returned, I was supposed to get almost 6 more adult birds than I got. I got almost 6 less adult birds. And I'm sure that's important. All right. 53. We're skipping 52. You need to go back and do 52. Start. He's at the bottom. Start 52. You need to go back and do that one. We're going to scoot on to 53. Oil and residuals. Oh, yay, more residuals. The Trans-Alaska Oil Pipeline is a tube that is formed from half-inch thick steel and carries oil across 800 miles of sensitive Arctic and subarctic terrain. The pipe segments and the welds that join them were carefully examined before installation. I would hope so. How accurate, are the field measurements of the depth of small defects? The figure below compares the results of measurements on 100 defects made in the field with measurements of the same defects made in the laboratory. The line y equals x is drawn on the scatter plot. Is that a good line for this data? No, it's terrible. Describe the overall pattern you see in the scatter plot, as well as any deviations from that pattern. This is the field measurement. This is the lab measurement. So this is, and if the lab equals the field, it should be here. Right? So that's the line y equals x. So what are we noticing? Isn't it lagging over here?
Yeah.
So what does that mean? If the lab says it's supposed to be 60, what is it really? It's below 60. Y'all with me on that? If the lab is 80, look at some of these. Look at him. If the lab measurement was 80, he's only at 50. Now, don't write, let's just think. 53. Describe the overall pattern. Okay, pattern. What are you supposed to talk about when I ask you about pattern? Is it linear?
Yes.
Yeah, sure. Linear-ish. I mean, it's not great, but yeah, linear-ish. What else?
Positive.
Positive. Because as yes, don't just say positive. Tell me as this goes up, so does this. Good. Okay. Talk to me about the spread of the data. Is it spread equally? Talk to me about the small lab measurements and the small field measurements versus the large lab measurements. Ooh, it's beautiful. Beautiful. Can you be a little bit more specific? Because they don't just spread more. Where are they going? Aren't they kind of sagging? Yeah. Okay. So as the lab measurements increase, they do spread out more, but they're also pretty consistently below the field measurements. No, that's not true. The field measurements aren't increasing at the same rate as the lab measurements. Ooh, that's good. Jump here. Let's do that one more time. The field measurements are not increasing at the same rate as the lab measurements. They are here. I like this. I even almost to there. But after you cross 50, whatever it is that we're measuring, the field measurements don't keep up. Do y'all agree? So I'm just noticing patterns. That's it. That's all I'm doing. Let's see. They said there is a positive linear association between the two variables. There is more variation in the field measurements for large lab measurements. Also, the values are scattered above and below the line y equals x for small dips, indicating a strong agreement, but the field measurements tend to be smaller than the lab measurements for large depths. So the field measurements are smaller out here, which we covered all of that. Good job. Do y'all see how you have to become like an expert in the Trans-Alaskan Oil Pipeline? Mm-hmm. If field and lab measurements all agree, the points should fall on the line y equals x, except for small variations in the measurement. Is this the case? Yeah, heck no, absolutely not. Explain. Well, I've got a lot of data sagging over there. It's not all on the line y equals x. Is that sufficient? I like it. Part C. The line drawn on the scatter plot y equals x is not the least squares regression line. Obviously, that's not the least squares regression line. How would the slope and the y-intercept of the least squares regression line compare? In other words, where would you draw the least squares regression line? What would you do to this line for it to be a good line?
Less steep.
Less steep, I like that. So, like that?
Yeah.
So how would the slope and the y-intercept change? Well, how would the slope change? It would decrease. Yeah, the slope would decrease. What about the y-intercept? Increase a little bit, not a lot. Yeah, I like it. Moving on. 59. Yep, 59. All right. Merlin's breeding. It says we've got data on the number of breeding pairs of merlins in an isolated area in each of 7 years and the percent of males who return the next year. The data show that the percent returning is lower after successful breeding seasons than the relationship is roughly linear. The figure shows the mini tab. Oh, good. Yeah, can y'all see that? I can't even, okay. So we're gonna just eyeball what the numbers are, because I know this is ridiculously fuzzy. But part A says, I want the equation of the least squares regression line. Okay, so here we go. Y hat equals. Where, even if you can't tell me what the number is, where is the slope? This says coefficient. Right there. Then this says constant. Then this says breeding pairs. So do we agree that it's this guy right there? That is where your slope lives. I promise to give you a mini tab that you can read. But that is your slope. And he is negative. I have to look at the answers.
6.65. Yeah.
All right.
That's a big one.
Hold on, what number is this? Yes, negative 6.65. I agree. And that is your slope. So I'm going to scoot him over. What is your y-intercept?
2,
Uh-huh.
6, 6.
Uh-huh.
0.07.
Yep. 266.07. So, just to be clear, I'm looking at those two numbers, right? The top one beside the word constant is your what? That's your y-intercept. Because think about it, y-intercept is a constant place. The one that's beside breeding pairs or mileage for your truck, that's your slope. Okay, well, I just wrote an equation. What did I not do? I gotta define my variables. Don't write it. Let's just talk. What is x? What are we doing? Yes. And what's y hat? Mm-hmm. Yep. Isolated area. And the percent of males who returned. Number of breeding pairs. There it is. Number of breeding pairs. Percent of males who returned. So X is going to be my input, which is the breeding pairs. And the Y hat is going to be the predicted percent of males who returned. Use the equation to predict the percent of returning males after a season with 30 breeding pairs. Let's not do it, but what would you do? You plug a 30 in for X. Yeah, you get your Y hat. Okay, moving on. B, what percent of the year-to-year variation in percent of returning males is accounted for by the straight line relationship with the number of breeding pairs in the previous year? What does that sentence sound like? What percent of the R squared? What's he called?
Coefficient of
Coefficient of determination. This, what percent of the year-to-year variation, the percent of variability, in percent of returning males is accounted for or explained by the linear model that relates the number of breeding pairs to the percent that return. And that's R squared. And he is right there, which I think is 74.4%. Is that right? 74 point who? 6.1.
Yeah.
I'll take your word for it. I can't see. Use the information to find the correlation coefficient. So how would I find R? It's not on the mini tab.
Oh,
I got R squared.
square root.
Okay, go ahead. Now, don't square root 74.61. Square root the decimal, 0.7461. Going in. Remember, R should be between 0 and 1. So don't give me a big number that's beyond that.
0.864.
0.864, anybody confirm that? Everybody agrees it's a 0.864. It's negative. Why is it negative? Because the slope is negative. Negative 0.864. Oh, how easy is it to forget that? Good job, Elijah. Way to catch that. Okay, interpret the, how do you know whether the sign is positive or negative? Slope. Interpret the value of S. Who is S?
Standard deviation.
It is the standard deviation of your predictions. So what's a good sentence for that? You give me a good sentence for that, we'll stop. When using our prediction equation to predict, what are we predicting? Percent of males that come back based on the number of breeding pairs. Our predictions will typically be off by whatever that number is right there.
0.762.
Yeah, whatever that number is. Okay, I'm gonna say it again. When using our least squares regression line, and you can call least squares regression line least squares regression line. When using our least squares regression line to predict the number of males that come back after a certain number of breeding pairs, our predictions will typically, we love that word typically, will typically be off by whatever your S is. Okay? Look, guys, I want you to put a star by D because I want you to practice writing that sentence knowing that it's in the homework answers. Okay? So we got to 59. That's not bad. You have 55, 57, and go back and do 52, so you have 3 left to do. And what? The Big Mac Daddy problem. I recommend flashcards. I recommend flashcards for your rubber stamp sentences. You need a flashcard for slope, for y-intercept, for residual, for R, for R squared, for S. I would make flashcards for all of that so that you get a hang of those sentences. You need to hand them to somebody and have them show you, okay, M. Then you read the sentence for M. They don't need to know stat. You don't have to study with a stats person to do that. Have mom do it or dad do it. Or somebody sitting in your chemistry class. I don't know. But you need to practice those sentences. Guys, I promise you they're going to be on the quiz. All of those sentences are going to be on the quiz. Okay? So be prepared. No curveballs. All right? You've got me in the mornings if you need me. You've got one more morning to come in here and do test corrections if you choose to. But you can also come in here Wednesday and Thursday morning to practice or to ask me questions or whatever. I'm here. Okay.